All right, we'll go ahead and get started. Good morning, everybody. My name is Walt Drain. I'm the Secretary of the ATP Education Division. I also serve as Cavion's Director of Education Services, and today I'll be serving as the moderator for this webinar. We're glad that you joined this webinar today. We've got a great conversation in store for you. Before we dive in and get started on that, though, I wanted to remind everybody to register for ATP. The upcoming conference will be held March 23rd through 26th. And today is the last day for early bird registration. So if you haven't taken advantage of that early bird registration, please go ahead and register for the ATP conference that's coming up this spring that'll be held in Orlando. Let's go ahead and get started today. We've got a better way to test will be the name of our Ed Division webinar. And let me see here how we advance slides next. Okay. Today's webinar, a better way to test. This webinar will explore groundbreaking advancements in high-stakes testing, focusing on the transformative potential of artificial intelligence and randomly parallel testing. As we look forward a future shaped by AI, this session will discuss how responsibly integrated AI can enhance fairness, accuracy, and personalization in assessments, creating a more engaging and inclusive experience that adapts in real time to a test taker's knowledge. Additionally, discover how randomly parallel testing can revolutionize test security and integrity by generating unique yet equivalent question sets for each test taker. This innovative approach not only minimizes content exposure, but also fosters an unbiased testing environment that provides a more authentic measure of a candidate's skills and abilities. Today, we have two esteemed featured speakers. Stephen Sireci is a distinguished university professor and executive director of the Center for Education Assessment in the College of Education at the University of Massachusetts Amherst. We also have David Foster, who is Cavion Test Security CEO and chairperson of the Cavion Board of Directors. At this time, I'll turn it over to Steve Sireci, who will begin his part of the presentation. I would ask everyone to hold their questions till the end. We'll have a Q&A at the end. Feel free to utilize the chat. I will be monitoring the chat as we go along, so drop questions in there if you would like as well. Steve, I'll turn it over to you at this point.
Well, thanks, Walt. What a pleasure to be here. It's nice to be engaged with ATP again. Not just ATP, but the education division. Many times when I go to ATP, I'm really immersed in the issues related with certification and some of the professions. But knowing that there's such a big community focused on educational testing at ATP is really heartening. So I appreciate the invitation today. Some of what I'm going to talk about today started in a presentation a couple of years ago at the ATP conference in February 2023, I think. So I apologize for any duplication if you've seen some of this before, but there are some new developments that are constantly changing. So I'll talk about, what some of the ways I'm seeing things and some of the things we're doing at UMass, and really look forward to what Dave Foster is going to share with us also, and hopefully have some time for a Q&A. Some of what we have is just about ready to pilot. If we have some time, I can probably show some of that, but we'll see. I'll try not to talk too much. But I want to start by saying, as you all know, educational testing is hard, right? We're measuring these large bodies of knowledge and skill. We want to, the whole purpose is to provide some useful information that people find valuable, that they can act on to improve instruction, to, evaluate systems and so forth. And we have to do that without taking up too much time, right? We don't want to take time away from instruction. We don't want to have people sitting there for longer than they have to. And in addition, one size does not fit all, right? We've got huge diversity if you think about the students that we're testing throughout educational assessment. So trying to address all these factors is hard. But we have some good news because, we have our new friends from AI. Here, a little picture of our test development team at UMass, these robots who are helping us. And we're using AI all the time. On the bottom left-hand corner, we have Google Translate, which you don't think of as AI, but of course that's AI. We have AI, helping us drive our cars and so forth. So that's the good news. We have our new friends, and of course, AI is only good, right? So what does this mean for the testing industry? So we have these new tools for content development, improved methods for automated scoring. What's happening in automated scoring has been really helpful. And then the idea of personalized assessment. And that's what I'm going to focus on today, where we can actually use technology to, instead of having one test form that everybody takes, have a form that's actually using information about the examinee to determine what to give that person. Another area where we're seeing some application of AI that is likely to help us is with alignment, and I'll talk a little bit about that too. And finally, most, if not all, educational tests are reported on a scale. We spend a lot of time piloting and calibrating items. And I think AI allows us to think about new ways of scaling tests too, that avoid a lot of the problems and the difficulties we have in doing things the way we've been doing for the past 100+ years. And who knows what else? So there are people listening to me talk right now who are probably doing even more amazing things with AI. And tomorrow we'll find other applications. So all of us are using artificial intelligence in our testing activities, or at least experimenting with them. So what I'm going to spend most of the remainder of my time talking about this morning is what we're using and researching at UMass, particularly with respect to the Adult Skills Assessment Program. So ASAP is kind of a new way of thinking about an assessment, in that we're not developing an assessment, but we're building a system that delivers assessments. And the assessments that are delivered depend on factors. And so it's kind of like this digital warehouse of assessment items and modules that are assembled in real time. And because of that, you can use the same system, same construct, but for different purposes. So the theory of action behind the ASAP is to provide information about adult learners' literacy and numeracy skills to help guide them to proper education and training so they can accomplish their goals. So everything starts with the learner. For those of you not working in adult education, there's tens of millions of adults across the United States who are not in the post-secondary system, never got to college, many who did not graduate high school, thousands of others who've come to the United States with degrees but are trying to learn English, and so forth. So it's just a huge need to upskill the American workforce. So part of our theory of action is that by providing this information, will help adult learners accomplish their goals, and also have assessments that are accessible to all learners, value their funds of knowledge. And by that, I mean, what are the different assets they have that can help them show us what they know and can do. Provide scaffolds when needed. So by scaffolds, if you didn't get an item right, do you get a second chance? Do you get hints? Those sorts of things. And providing, again, actionable information is what this is all about. Now, one of the things that's important for everyone to realize as they're listening to me is our world is not just high stakes testing, right? So that allows us to do some different things where, we don't have to have like security being our main concern, or, lots of people trying to cheat. A lot of the assessments that are actually designed to help learners are like, eye exams, where you're not going to want to cheat to get the wrong prescription. Theories of action: if the picture is not too big, a picture is always a little easier. But like I say, everything starts with the learner over here on the left side. They interact with our system, and the system is going to provide information on numeracy and literacy that's going to inform the learner themselves, the teacher, a counselor, employer, that leads to some action. And some of that action might be more testing, or education, training, hiring, certification, and so forth. And because adults are adults and they're in the work, most of them are in the workforce or trying to be in the workforce. The idea of bridging a lot of the curriculum we have and the curriculum standards in adult education to what are the knowledge and skill demands on the job. That's been the trickiest part for us is bridging workplace and adult education. And at the same time, we're excited about and want to take advantage of culturally sustaining assessment principles. Now, to accomplish all that, of course, we're going to leverage our new friends, our new tool, AI. So we're using AI in these different categories, probably categories that you all are familiar with, in test development, developing items, putting sets of items together, facilitating culturally responsive assessment, in designing assessments, building in choice or variations of items. And then with respect to psychometrics, can we scale based on the features of the items? What can analysis of the features of the items tell us about the complexity that we can replace difficulty scale with? I mean, can you imagine not having to pilot items on hundreds of thousands of people to develop a scale? We can actually develop a scale using features of item attributes. So that's what we'll talk a little bit about today. And then there are other possibilities, like what about feedback, right? If we want to use assessment to improve instruction, and if we want to align curriculum assessment and instruction, feedback's a critical part of that, right? If we're going to help people. And that's really hard, right? So if someone's taken an item, they've gotten it wrong, what do you want to tell them? And how do you tell them? That's a really, really laborious task. So I think it's a great possibility for AI to help us. And maybe some of you can talk about that today. And of course, also in score reporting. So the Adult Skills Assessment Program is one example of personalized assessment where the goal is to develop the best assessment for each individual person. It's consistent with the idea of under-standardization that I've been talking about for a few years now. So Educational Measurement Issues in Practice, the journal that all NCME members get. This is a really short article that I recommend for people, 6 pages, 7 pages to learn about personalized assessment. Heather Buzik and her colleagues. Same journal is something brief, again, just 6 pages. Standardization and under-standardization. And then we just published in the same journal an article that's going to cover a lot of what I'm talking about today on dirty assessment, design and real-time assessment, and using the ASAP as an example. All right, so moving forward on using ASAP as an example, let's say the purpose for a particular learner, a particular employee, is to confirm that they can read and understand safety guides and users manuals used on their job. So we've got these sets of items in the warehouse, and based on that testing purpose, we've got some test specifications. So we know for a certain level of reliability, it's going to be 20 items, 4 modules. Scaffold level 2 will dictate some constraints about, because there's a certification purpose here, maybe it's proctored or whatever. And then there's a subset of modules in the warehouse that fits these demands, and then they're pulled together in real time to develop the assessment according to these specifications. So the one layer that we add to this, right, typically we've got these 2 layers here, testing purpose, dictates the test specifications, so you develop the test. But then we've got this 3rd layer over here, which are the personalization options. So given that here's somebody we know is working in food preparation in the confectionery industry from Arkansas, what can we ping in the warehouse that we can pull into this compiler that now compiles the test in real time here? So the idea is just to do whatever we can. The idea is to develop the best test we can for each individual person, each individual learner, rather than trying to do the best job we can developing one test for everybody. Now, the best test for each person is an ideal goal. So it becomes what's the best test we can given the constraints that we have in our item bank and so forth. With respect to item development, lots of people are using chat and other generative AI for helping with item development. So I'll show a couple of examples of what we're doing, and then I'll just briefly touch on some of the research we're doing to compare AI engines and to evaluate the products of what we're getting out of them. So if we take a standard like this, and what do we have here? This is the conversation with chat. Write a reading passage appropriate that measures this curriculum standard for adults who read at the 8th grade level. And this is what we get, something on exercise benefits. And we can evaluate, well, the Flesch-Kincaid score is about the 8th grade level. That's good. Now, give me the same passage, but it's about something different. A passage at the same level, but on a different topic. So if we want to give someone the choice, do you want to read about exercise or civil rights? And we could keep interacting with chat and keep editing until we get something of comparable um, reading level, reading complexity. And also we have to look at the items, right? And see, we've got here reading complexity levels for each item. So knowing that we can get these things across the different types of things we might want to put in front of people to read, we can actually use that as a constraint in test design and use AI to generate items subject to those constraints. ChatGPT 4 has been performing better than 3.5, of course. More item type alternatives, been suggesting images. We're getting better alignment to the standards we're trying to measure, but it doesn't mean the humans are out of the loop, right? We still need human in the loop for revision and verification. It tends to give us items that are too high in complexity, so we need to iterate, tell it to reduce the linguistic complexity. When we try and use it to generate items that are culturally responsive, it's not great at that. So we have to train it and give it more specific prompts. And sometimes, as you know, it'll generate items that are impractical. So here we see just some of our team of students at UMass have been working at this. I'm going to reference some of the research they've been doing in a minute. And the conclusion of that research, you won't be surprised, is that humans still need to be in the loop. But we have to remember, all the criteria we use for evaluating items when humans are developing them still applies. So just as one example, the items only have one correct answer. So we could see when we compare across the different generative AI, there are some real differences. When we look at the data we get from humans who are evaluating the AIs that are generated, that are evaluated the items that are generated by AI, for this particular set of items, 100 items or so, about 36 of them, 36% were aligned and were seen as following the item writing guidelines. And so we thought, well, that's not bad. You know, we got a third of the items that they generated we can actually use. But then what are some of the problems? So I think it's important for us to remember, let's document those because we can help improve the AI generation of the items we're going to subsequently get. So that's one take-home message for today. Using AI in test design, the question is, can we use AI to personalize assessments subject to constraints while retaining validity and comparability? So what I was talking about before, where there were some choices in what to read subject to readability constraints, choice in the context of the assessment. So is it in a different workplace context, depending on who's being taught? And then with respect to culturally sustaining, the idea of mirrors and windows. So this is something I got from Jennifer Randall. And the idea there is tests should be a mirror so people can see themselves and see their own way of life and culture in the assessment. But also don't send them down a rabbit hole and that's all they get. Tests can also project other cultures and other ways of life. So, and we can actually determine a priori the percentages of mirrors and windows that we want. We also know, and I don't know, I don't think Dave will talk about this today, but one of the things that Cabion's test delivery system supports is like alternate language versions of assessment. It's getting easier to translate using AI. So even if your assessment, you say, needs to be in English, having the directions in a native language can be super helpful. And there, we're talking to lots and lots of employers who are hiring hundreds of people who operate like entirely in a different language in the workplace in Spanish, but they still need to be able to read English to work machines and so forth. So having the choice in language can be just a really good way to improve the validity of the assessment. Choice in scaffolds, just as an example of, you know, what language would you like to take the test in? We're going to give you something to read. What would you like to read about? Again, rather than saying everyone, here's the passage we selected for you. So let's say you choose on sports. What article would you like to read? You chose football. So here we have an item that's measuring a vocabulary word. Let's say you chose sports, but we gave you women's basketball, or we know that maybe you're more interested in women's basketball. Same standard being measured. If we look at the difference between the usage of the word or the readability of the prompts, they're within the constraints we've imposed. So really quick, I feel like I'm running out of time, but that's how we're not just using AI in item development and test development, but evaluating it as we're doing it. With respect to alignment, it's hard. It's hard, as I mentioned. One of the things we're trying to do is bridge the workplace with the adult ed curriculum standards and what's being taught. So here's just an example where we're feeding into chat some training data, Texas standards. These are standards that were done in Texas that looked at some of the college and career readiness standards in adult ed and how they dovetailed with respect to the job tasks in ONET, and then use these models to match the reading standards to ONET, and then generate some human verification so we could see which ones actually map on in a way that will be informative, because we're writing items to the CCRSAE, and wouldn't it be great to also see how they tag to ONET.
About
So
2
the
minutes
AI has
left,
been
Steve.
helpful, not great. Was that my 5-minute warning, Walt?
Yep.
Thanks, appreciate that. All right, I think this is one of the last things I want to talk about is using AI to replace calibration and scaling. So again, right now we're dependent on piloting items, either in our operational tests, or if we have a new testing program, having lots of piloting before we can develop the test, administer the test, develop score scales. The idea of item complexity scaling actually goes back to the work of Gerhard Fischer and Susan Embertson, who were trying to think about what the B parameter, what the difficulty parameter in item response theory represents with respect to the knowledge and skills measured. So just some amazing work there. And the logistic latent trait IRT model, for example, kind of has this other model that describes item attributes that predict difficulty. So we're kind of using that logic to see, well, that regression line, could that actually be the scale? And at the same time, if we could use machine learning, natural language processing to figure out what's the complexity of each item given the attributes of that item. Because if you think about it, all a scale is, like an IRT scale, for example, or any standard score scale, is it's a way we're computing distances among items and configuring them across the scale. Same thing with people. We're just lining people up across the scale. So the idea here is, can we do scaling without piloting? Of course, you still have to pilot different parts of the testing program. But this idea of using AI and other ways of coding item features to create a scale. So here we see some results. This is just results from regression. Again, these are some of the students at UMass. And here you see, we'll start with the strict non-AI linear regression procedure. These features are predictors. So if we have just the linguistic features of the math domain they're from, and then we add the level the item was written to, we're predicting just with those variables, 58% of the variation in the item Bs. If we add some domain group and cognitive level, we're almost up to 60%. Not great, not where we want to be, but these are, college faculty and graduate students coding math items first shot out the door. If we look at the results from the using AI models, so fine-tuning, ChatGPT, for example, it's given us 43% of the variance accounted for, again, straight out the door. So we're looking at these results as pretty positive that we should continue work in this area. So to summarize, advice for educational assessment, how do we use AI? Well, the debate about whether we should be using it, I don't even want to partake in that, because, who's not going to want to use a new tool? So it's not that it's a friend or enemy, but a new tool that we have to figure out how to use it in a way that does more, that helps us and doesn't hurt us. So that's the conclusion. Use AI to help design, develop, administer, report scores, not replace all these things, but to help us accomplish these things. And these tools not only will evolve, they are evolving, and we'll get better at using them, and they will get better at doing what we're trying to use them for. I think the benefits are going to include reduced dependencies on pilot testing. We can release more test items, right? People complain, we can't see the ad. Let's release the test items because now we could just generate more. And also more personalized assessment and more feedback. But these potential benefits have to be evaluated with research. I'm talking about validity research. And I'm well aware of how, when AI generates stuff, it can be really, really ridiculous. And if you look at, this is online, if you go to the International Test Commission's website, they have a newsletter there. And the newsletter I think it was in June, we just talked about how ChatGPT wrote this whole article on the contributions of Jerry Garcia and Robbie Robertson's criterion reference testing. Totally silly, but it's a good read if you've got insomnia one night. So that's it. I just want to thank Walt for the invitation, and hello and happy holidays from all of us at University of Massachusetts Amherst.
Right. Thank you, Steve. Next, we'll hear from David Foster.
Okay, hi there. I'm just getting my sharing my screen. Assume you can see that. Sorry, Walt, you can see my screen, right?
Yes, sir. And I can see your PowerPoint being pulled up now.
Okay, thank you. Then I've got to. So I'm really happy for the opportunity to be here and talk about my favorite topic past few years, randomly parallel testing. A simple solution to a lot of big problems, and just a little bit of this. If you've heard me talk about this topic before, I almost always present evidence of why it's how well it works. And today's session is going to be more about why randomly parallel testing is important, why you can trust it, and why you can do it fairly easily. I will mention AI, but the focus for me on AI isn't to improve the current way we do testing, but is to today introduce a new way of doing testing, and then notice from that how AI can be more productive and helpful once kind of a new way of testing is in. How can it help that? So hopefully you'll see the AI piece of it, but mostly this is about a fundamental change in how we change our tests. Okay, hold on, I'm just advancing. So why care about randomly parallel testing? So it all goes back to our industry's problems and needs. Here they are. A few people doubt these. Cheating and test piracy is pretty rampant. No test score is free of its contamination, and so it's hard to do that. It's hard to make decisions about test scores if you do or don't know that cheating has happened. But anyway, unfairness is a second one, and Steve has talked quite a bit and really well about that, as he always does. Tests today have limited shelf life. Give them so many times, and then they become kind of exposed and unusable. Often just one exposure will do it these days. They're barely repeatable, mainly for that reason. And we need repeatable exams. Copywriting is a problem, difficult to do today. Tests are expensive to build. They're expensive to give. They're inconvenient to take. And because of the issues of error and such that exist in current testing approaches, test scores don't generalize well to what we want them to generalize. We want an exam score to generalize to an entire domain of learning or to an entire job domain a person works in, but they don't do that well, and much of the reasons are and mainly because you have cheating and piracy problems, but others as well. And we can expect more of this kind of problem, of these kind of problems in the future, unless we make some sort of change. So these needs and problems can be directly tied to the way we currently build and give tests. Then security problems are not really tied to the fact that there are cheaters out there who don't care about our tests, and they are, no, it's not. It's the fact that we build tests that are easy to steal and easy to cheat on. So they're tied to our traditional way of testing, almost every one of these. So what are that? What do I mean by traditional types of testing? So static test forms given over and over again, multiple choice questions used almost universally, limits on number of items or test forms created, static items used over and over again, pre-testing items for statistical properties, tests given in fixed locations, human proctors monitoring test takers. None of these are actual testing standards. They're not actual requirements that we have to do. They're just simply methods that have been used for sometimes more than 100 years, but that are open to evaluation, to change. And in this day of technology, that's pretty good news, and we should pay attention to that and see what we can do. They can all be replaced by something better. Another note, I realized there are some exceptions to one of these in this list I wrote. So it's not 100%. So there are some exceptions. I didn't call them out specifically because of time. So our history of traditional testing began in early 20th century. And by the way, it was the most amazing innovation in testing in centuries when we switched to this kind of traditional approach. At that point, it was extremely modern. Today, it's traditional, but over the years, it became institutionalized, which means that it resistance to change. Once you institutionalize something, you defend it, you keep it that way for as much as you can, as long as you can. Still today, 100 years later, with all the new technologies we have, including AI, we're still giving tests in the same way. By contrast, every other industry that began at the same time is now pretty much unrecognizable. So let me give you some examples. So this is why we have the problems we have, and this is why we need a better way to test this year and going forward. Let me just show you some innovations. This is telephones invented around the early 20th century, and you can see by today, we went from that phone on the wall to smartphones. And now what's the future? Wearables, implants. So same pattern for cars. The old horse and buggy, and you know, the original horseless carriage, all the way up to the amazing types of cars we have, the electric cars, the self-driving cars, and you know, flying cars are probably in the future. And then computers didn't start in the early 20th century, but they started in the 50s. And our smartphone is like, I don't know how many more times powerful than those original computers, but you can see the trajectory is really steep. And now this is our testing. I've labeled it multiple choice items. I should have changed that label. This is really traditional testing and all the aspects I mentioned. It hasn't really changed much, maybe a slight uptick in some of the exceptions I mentioned, but by and large, we do the same thing we've done. We just do it with computers, maybe a little faster. So that's something wrong with this chart. So what's the solution? So the first, very intelligent person made this quote in 1955 in a reaction to, or as an alternative to the kinds of traditional testing that he saw. And by the way, by 1950s, those traditional testing practices were already institutionalized. So he's coming up with some alternatives. So he says, if the items in two or more tests may be considered to have been drawn at random from the same large pool of items, the tests are called randomly parallel tests. He's making a case for equivalent test forms simply on the basis of randomization. It's a process that occurred in science, a long time ago, and he definitely knew that. So he makes a statement. So it was Fred Lord. Just a little bit about him. Began working at ETS in 1949, got his PhD from Princeton in 51, and over his career of 33 years, he really became our industry's greatest of all time. Few people, I don't know anybody that would disagree with that, but there probably are people, but he is the greatest of all time. He's produced the books and papers that have become just required reading. And so in 1955, this was the person that recommended the use of randomly parallel tests. And he continued to do so throughout his career. So I'm just repeating it again, so you understand the simplicity of what he's calling randomly parallel tests. If the items in two or more tests, that is to two people or the same person twice, doesn't matter, may be considered to have been drawn at random from the same large pool of items, the tests are called randomly parallel tests. And he would often use the term randomly equivalent tests. So parallel and equivalence mean the same thing in this case, probably in most cases. So he also stated in 55 that randomly parallel testing seems to have as good justification as those usually used, and perhaps better. He's proposing it and he thinks it may be better, and so he says it at the time that is something we should look into, and he definitely looked into it over his career. So in general, it's the simplest testing approach I've run across. It has the strongest theoretical foundation. It has the strongest statistical support, and it has the easiest to meet assumptions. That is, if you do what he said you do, make a large pool, pull items randomly, then this particular approach is a great way to give each person an equivalent test form. But alas, the bad news. And it was just really more of a delaying bad news. There was no technology available in the 50s to do this. You could maybe do it in research, and it was done in research, but to be implemented operationally, the technology wasn't available till the 80s or 90s, at least probably the 90s. So traditional testing remained dominant. There were some changes. His notion of randomly parallel tests saw its way into generalizability theory and other versions, but the traditional testing remained dominant despite those, and is today dominant. So the concept was generally forgotten for many decades. Those papers he wrote. So I've been making an effort to resurrect them a bit. And you can learn more about them, but just going back to Lord's papers would be great. So 50 years until the technology caught up to randomly parallel tests. And then it took us 20 more years to remember what he wrote and to begin to implement this, which was just about 5 or 6 years ago. So we caught up after, we probably could have done this 20 years ago. But anyway, better late than never. So I just very briefly want to, what are other discoveries that took a while to catch on? So I'm going to talk about solar energy, which was originally the first theory and approach to it was in 1939 by the Frenchman Becquerel, and then the first solar cell in 1839, 1883, the first solar cell, and in 1974, there was U.S. legislation that recognized the value, and since like the 70s, it's been growing very steadily. Okay, so hand washing for germs, 1847, the importance of it was recognized by Semmelweis, became regular practice after 23 years, And then in 1980, it became a US national standard. The harm asbestos causes was originally recognized in 1899 as curious bodies in the lungs of asbestos workers. And in 1935, a cancer link was discovered. And then in 67, the US passed the Clean Air Act, essentially prohibiting the use of asbestos. But today, might not surprise you to learn that it's still commonly used in many areas of the world. Now, so that's 135 years for solar energy, 133 years for hand washing, and asbestos took 68 years to get to that point. So on RPTs, better late than never. We have a couple of individuals who are also researching and recognizing the potential value. One is Bob Brennan from the University of Iowa, now retired, but he presented a paper on the topic at the National Council on Measurement and Education in 2024, which last April. And that particular presentation is now published as a paper in Educational Measurement Issues in Practice. It's right now it's a online access, and early next year it will be published in a paper version of the journal, or what's it called? Yeah, special issue of the journal. And then it's been accepted to present another paper on randomly parallel tests along with some colleagues at NCME, this coming NCME. So it's beginning to get some serious attention from very notable psychometricians and experts in our field. And another one, this is somebody you'll probably remember, Steve Sireci, on randomly parallel tests. He and I presented on this a couple of years ago at ATP. And this is a quote from one of his slides. He says, "It's important to note, random does not mean disorganized. On the contrary, smart testing agencies use randomization in explicit ways to increase test security, facilitate parallel experiences for test takers, and ensure comparable score interpretations." So I'm switching now. We're back to the present day, of course, and this is just I'm going to repeat the original set of problems and just what RPT effects it has. And so for cheating and piracy, almost all test fraud is eliminated. And I use that term very literally, gone. Unfairness supports the personalization of exams as one example. Limited shelf life. Exams with randomly parallel tests are effectively immortal. They last forever on the shelf until they need some updating. But updating because the content changes, not because exams have worn out or gotten stolen. Barely repeatable is the problem. And now with randomly parallel tests, they are pretty much close to infinitely repeatable. Copywriting is unnecessary. Expensive to build. Randomly parallel test is the simplest and least expensive test design. And once you've built it, as it says above, it has it's effectively immortal. You never have to maintain it in the sense of always replacing the content, creating new exams. So in that sense, it's really inexpensive to build. Inexpensive to give, to deliver the traditional test. The improved security reduces costs. I'm expecting that this will have an effect of removing the need for proctors eventually. It's not there yet, but it's getting there. So once you have eliminated many traditional security procedures, the costs go down, which means tests will go down, test costs. Traditional tests are inconvenient to take. Again, improved security provides many more test delivery or test taking options to examinees. And then test scores that don't generalize. Well, one primary feature of randomly parallel tests is that they produce test scores that perfectly generalize to domain to domain mastery, mastery of any domain. And then more of the same in the future. If we stick with traditional testing, randomly parallel tests, simplicity actually jumpstarts a new future. It's like almost kind of square one. And this is where AI becomes pretty exciting, as well as the many creative ideas that people can come up with once you have a system in place that's as flexible as randomly parallel testing. So it's the simplest testing approach, as I mentioned. It's easy to understand. It's not that complicated of a process. Lord's papers. I wrote a bibliography, an annotated bibliography on the topic that you can get off of Cabion's website or by contacting me. It's not hard to come up to speed on what it is. It's easy of testing models and methods to apply, supported by basic foundational statistics. It has so much. The assumptions are so easy to meet, whereas they're much more difficult to meet in classical test theory and some of the other theories we have. So it's nice to know that the entire field of statistics is 100% behind it. And so I give this as a great example of Occam's razor in action. We've got a fairly complicated and traditional and institutionalized system, replacing it with, easiness and simplicity with tremendous benefits. So definitely worth looking at it, right? So only two things are needed. And I only have a couple minutes, I think. You need a large pool that cover a job or learning domain. And you need a way to sample those items randomly so that everyone gets a unique and randomly equivalent form. That's it. That's what you need. That's all that's required. Now, to create large pools, AI, AIG, automated item generation, and smart items can help with this. So getting to a large pool is probably not as difficult as you're imagining at this moment. And by large, I'm referring to massive or nearing, I know I say it because it'll scare you, but really, really, really large pools can be built pretty quickly with technology. And this is where AI may come to shine. And then for the second point, most systems already support this already, but they do it in a very limited way. Not the randomization part, that's perfect, but they almost always have really small pools. So it's already, they built the technology. Now we just have to build the size of the pool. So number two is pretty much done in almost every testing system out there. So anyone can do it. It's a piece of cake. And I don't say that lightly. It is really quite easy. The hardest part is believing it, is thinking you can do it, or is abandoning what you've been doing. But actually doing it is easy. So there is evidence of its effectiveness. It's routine use today in some programs. There are data simulations that model the performance. There's scientific research studies published. So that's what I usually talk about, but I'm not today. So, so what's the future of testing like? I'm not sure. I know that many of the problems will be solved, and that's going to be great. But where we're gonna go, I just have, I have this quote: "It's not the complicated things that let us move the future, but the simpler ones." And so we do have I think, an amazing opportunity for the use of AI, for the use of any new technologies, as long as we're not trying to simply improve our traditional way of testing. And so the possibilities, it's a blank slate. You can do anything you want. You can fix all the problems. I'm probably can't tell, but pretty excited about what the future might be like. So thank you for attending.
All right. Thank you, Dave. Thank you, Steve, for providing that great information to us today. I'm going to open it up for questions and answers now. So feel free to put questions in the chat, or if you would like to come on camera, feel free to do that as well and ask your questions. Will the presentation be shared? Yes, it has been recorded, and I will find out from ATP how that will be shared. I'm not sure if that's posted on a member page or emailed out, but it has been recorded. Dave, this question's to you. How do you link randomly selected items to an exam blueprint and respect the desired balance between test objectives?
Okay, that's a great question. One of the when Fred Lord, even back in 55, when he suggested this, he said you can do randomly parallel testing, which is great. You can also stratify the pool, the domain, into contents and weight them differently, and then randomly draw from those strata. So the way you do it is by just organizing your pool in ways and then weighting and pulling different numbers of items randomly from the different strata. I hope that helped.
All right, got a question in here. What characterizes those trying RPTs now?
Sorry, say again.
What characterizes those trying RPTs now?
So far, and it's probably not a surprise, the IT certification organizations, which suffer more probably from test security, although everybody does, than those are groups that are some of them have jumped full into the pool, others are dipping their toe in the water, including one very large one has announced its intention because it's sick and tired of the security problems ruining not just the test score interpretations, but also all the careful psychometric work they did to build their exams. So they're tired of it. They're going to do it. We're meeting with them regularly. I expect them to move to this in the spring of next year. And so there are those that characterize, and most of it's in the IT, but not all of it.
All right, thank you, Dave. This one's also to you. I want to follow up on the copyright issue. Are you suggesting that copyright becomes less relevant simply because the item pools are so big?
That's kind of what I'm suggesting. And the bigger they get, the less relevant copyright. And so at some point, it's not needed because you don't care. You won't care that an item gets shared, captured, harvested, and sold on the internet somewhere. You just won't care. And so if you don't care about that, you won't care about copyrighting them. There'll be so many anyway. I mean, there'll be a lot. Uh, so that's what I meant by it. You're correct.
All right, Dave, also to you with randomly parallel tests, how do you prevent the same really good items from being selected repeatedly over good items? We have many items with stats that meet specs, but they don't get selected because better items are repeatedly selected.
Well, in that sense, then random selection is a great equalizer for items. If you have good ones and great ones and some not so good, but you have actually qualified the entire pool, you've run it through a quality assurance process that doesn't require field testing, but you've run it through and you're pretty happy with the pool, then you let randomization equalize those differences. There'll be no respecter of one question over another. You could stratify and by item quality, but probably no need to do that. So you can be sure that all items will be, based on your design, you can be sure that all items will be equally utilized.
Dave, also to you, do you need IRT for randomly parallel test?
I know you don't. IRT, the theory behind randomly parallel tests is a statistical theory called sampling theory, and which Lord called item sampling theory. So that's the theory behind randomly parallel tests. Item response theory requires the particular statistics for the items. You have to calibrate them and you have to get the statistics. Randomly parallel testing does not require those items to be calibrated. So it does not require IRT. Sorry, and I just want to add, there are probably applications of IRT that can be definitely used like adaptive testing as people develop randomly parallel tests. So that's a bit of a future thing, but not far off.
All right, couple things. Just real quick to follow up on the recording, was able to confirm it will be uploaded to the ATP YouTube channel, and the link will be added to the website and on the Education Division webpage. One more question that just popped in. Dave, how is this different than on-the-fly testing other than having the AI generation of items? Maybe item calibration is the difference?
That is one difference. Linear on the fly tests usually are part of the selection process. Some of it's random, but some of it is also based on statistics. But the bigger reason probably is the size of the pool. Linear on the fly tests usually are confined to a small set of items that you can field test. Randomly parallel tests are released from that restriction, and therefore the size of your pool can be huge, and it doesn't have to be physical items. It can be virtual items that are actually built on the fly just prior to giving it to a test taker. So you can build systems for the pools rather than having 1 million items or 10,000 items in a pool. You can calibrate engines, very similar to what you might see in automated item generation templates. Okay.
All right. Well, thank you both to the presenters, Steve Sireci and David Foster, for presenting this great information to us today. Just a reminder to everyone that today is the last day for early bird registration if you plan on attending ATP in the spring. So please go register for that conference. And thank you for attending today's ATP Education Division webinar. Have a great weekend.
Thank you.